Good afternoon, everyone. I'm Doug Grant, one of the partners at Insurance-Canada.ca. It is our pleasure to be hosting this webinar today as we look at modern data platforms dealing with disruption in the era of advanced analytics and AI, brought to you by Xby2. Our speakers today are Ahsan Siddiqi, Director IT and Data Strategy, and Syed Haider, Director IT and Data Architecture, both from Xby2. Xby2 is an IT consultancy focused on the practice of software and data architecture in the insurance and healthcare industries. This webinar is the third webinar and fourth event in our series of webinars and seminars under the umbrella Technology in Action that we are offering. Thank you for your interest and for attending. Before we begin, a few administrative details. As you are listening, should you have any questions you would like to address to our speakers, please enter them into the Q&A box. You'll find that is one of the icons, most likely at the bottom of your screen. Following the presentation, our speakers, Ahsan and Syed, will answer questions you have asked during the event. We are recording the webinar. We will send a note out to you within the next day or two with a link to it. We would appreciate as well any additional comments in an email about this session, about the topic, or about other topics you would be interested in hearing about. And now, just to get the session going, here's my introduction. Data has been called the new gold. Good data and more data can yield a competitive edge, provided that you collect, manage, and process it to your advantage. We have certainly been seeing innovative ways of using data over recent years in the insurance industry, in areas from marketing and sales to underwriting and rating, new product development, right through to claims and reinsurance. Not to mention, perhaps the most important of all, customer engagement. Today's presentation should let you checkpoint your current activity and hopefully bring some new thoughts and ideas to your planning and preparation. On that note, let me now introduce Ahsan Siddiqi. Ahsan, over to you.
Thank you, Doug, for the kind introduction. We welcome all the participants to the webinar. Thank you very much for joining us. We've prepared some excellent content that we hope you'll find useful. You would be able to find some application within your organization, or at least would help you start some conversations around your data strategies. As you know, the theme of the discussion today is around modern data platforms and how the new class of use cases that have emerged for advanced analytics and AI, how a data platform is going to support them. We would look at, some of the challenges that we have with the existing data warehouses, how to evolve them to get them ready to support what the modern business users need. By the way of the agenda, we have broken down the webinar into a couple of topics that we'll discuss. We'll start with we'll take a look back at the basic enterprise data needs. What are the basic data needs that enterprises always had, and what traditional IT response has been in addressing those needs. And we'll talk about what kind of architecture was developed to deliver on those enterprise data needs. What were the complexities in those architecture, and what were the challenges that architecture was not able to deliver as efficiently as many of us had hoped. And then we'll look at the traditional, we'll peel it and look into the actual stack of the architecture, and we'll look at how that could be evolved into a modern data platform. So let's talk about the enterprise data needs. As far as the enterprise data needs are concerned, they haven't really changed much. Everybody sort of, whatever they wanted many years ago is the same thing that they want today as well. And they sort of boil down into a couple of key classes of requirements. The very first is that the business users are usually confronted with their data spread around various systems. And it is always hard for them to gather data from various sources and to be able to do some meaningful analysis, meaningful reporting, and they had very high level of reliance on IT to help with the data analysis. So they always had this desire that, hey, if we could get data in a consolidated form from various sources, that's going to help us a lot. You know, a lot of legwork they have to do or rely on someone else, they can bypass that process if consolidated data was available. The second was that, okay, if the consolidated data is available, I would like the ability to have quick access and simple access. Quick access means, you know, hey, data should be refreshed fairly quickly. You've given me some data, but it shouldn't be stale, and then I should be able to access in a very simple way. I should be able to connect it with my Excel, my basic BI tool. I should be able to pull an extract and use it. Another important need that businesses had, that they would like to preserve the history in the operational system. So in most of the operational systems, we know they're not meant to preserve a lot of history. Their focus is mostly on performance, response time, etc. So they don't maintain a long history of data. But you may want to, from a reporting perspective, you may want to find out 5 years ago what a customer record looks like. What was this customer married at that time? What kind of insurable risk that person had? What we could have cross-sell that person. So all of that historical information is useful for analysis. So they would like a way that gives them the ability to go into the historical information and do some reporting. And then they also wanted to have some kind of governance on that data, so that the data that is shared across the various business units has some common meaning. There is some common consensus. You know, they can control how the data flows. You know, some kind of data governance for use of and share of data was important. And the third and the last was, if you have data at one place and we are applying some common standards, but at the end of the day, each department wants to use that data for their own customized purposes. They don't want to be like overtaxed with whatever the organizational consensus has been on data. They would like to apply their own business rules, their own logic, so that they can use that data for their own purposes. And their definitions of data interpretation may be different from others. So that sets the context of what the enterprise data needs had been. Now, if you look at the historical perspective IT had in terms of servicing businesses, their focus has been mostly on managing business systems. Their focus has been on keeping the lights on, providing stability, reliability, and availability to business users. And business users, in turn, would only be able to use the reporting and analytics capabilities that were available within those systems. So if a system only allows a person to pull a list of customers and with a couple of filters, that's all they could do. If they need some other information, if the system's UI does not allow them, they were fairly limited by the availability of reporting within those systems. But as far as real life business and analytical needs are concerned, you need data from various sources. You need data which is much more richer. You need data which is beyond what the system UI provides, so that you can run useful analytical needs. So what IT did in response to that requirement, they say, hey, we can give you a backup of operational systems which will have all the data, and you can do your own analyses. And it did provide a little bit of relief to the business. They were able to pull some of the reports, the data that wasn't available or visible through the UI reporting, they were able to access and report on them. But it solved only partial problem. They were still not able to connect data from one source to another. So an example would be, if you are processing claims, you need information about the policy. You want to know what coverages were there so that you can appropriately process a claim. If you are running a marketing campaign, you also need information about your customers, your members. Do they still have a policy, or have they chosen not to renew the policy? So what it means is that all of these users need data from other sources as well. And what it resulted in, these business users going to other systems, making a local copy of the various systems. And it resulted in very severe defragmentation of data, growth of, sort of uncontrolled IT silos, or shadow IT, sometimes we call. And it created a sort of a difficult problem to manage. So while IT was trying to serve them by providing them these backup data sources, they realized we need to come up with a new solution. And the entire industry started to look into that, and they came up with a solution that was, hey, let's centralize all of the data at one place. That way we can better manage it, we can control the fragmentation, we can provide some governance, etc. And that pattern emerged as an enterprise data warehouse. The idea was you'll bring all of the data at one place. IT will manage the sourcing of the data, upkeep and maintenance of the data warehouse, and all the business users would just go to the data warehouse and use that data for their own purposes. So it did provide a lot of benefits. However, it created a bunch of challenges as well. So we're going to go into those challenges, but in terms of the benefits and the promise that it provided, it provided one place, consolidated source of data. It provided the ability to govern the data from one place. It provided the ability to abstract out the nuances and the differences in the various data that is coming from various source systems. It provided the ability to deduplicate the data. So for example, customer information can be in the policy, in the claims, in the CRM. So, deduplicate the data and have one representation of that data, for example, within the data warehouse. So it provided a lot of benefits. However, the architecture that was built for the data warehouse had some inherent shortcomings as well. And EDW struggled in dealing with those shortcomings or coming up with solutions for those. So one of the biggest challenge was speed to market. And what I mean by that is, whenever you have a new data source, ingesting that data into the data warehouse, taking it through all the layers of the data warehouse and making that data available to a specific business user was fairly cumbersome and time consuming. And business users said, hey, when you were just giving me very basic backups, it was much, much easier. I requested my applications team to make some changes into the application so that I can capture additional data. And in the past, when they used to give me daily backups, I can start getting the new data right away within 24 hours or 48 hours of deployment of that application. But now it takes a lot of time for me to get the same data, because it has to go through the governance process, the conformance process, the data has to be integrated, deduplicated, etc. It's a much, much longer process. So EDW actually struggled how to crack that cookie. Other problems it had was data accessibility. So in the data warehouse, you typically have maybe 15–20% of the enterprise data. You don't bring everything else within the data warehouse. But if your use case requires, that 25th attribute or the 26th attribute from some table, which is not in the data warehouse, you're in bad luck. EDW architecture also had problems with flexibility. So we know the IT ecosystem around the data warehouse from where it feeds is always in a state of flux. The systems are modified, systems are enhanced, systems are modernized, systems are replaced with new systems. So all these data sources continue to change. And every time the data sources change, you go into a major overhaul project of your data warehouse pipeline. Say, okay, now a different data source is coming. The data is different. How do I ingest it into my data warehouse and make it available to the business users? Scalability and elasticity was another big problem. With a traditional data warehouse, you would always go for big budgets. You will try to estimate what the resource footprint is going to be, how many server storage, compute power do you need, and you make a big purchase. And then over a couple of years, you try to make use of it, and then after a couple of years, you go for another big purchase if there is an additional need. So that is a very inefficient use of resources. You never had the ability to scale it up and down on demand as needed. So scalability became another bigger challenge. So with those problems, architects were challenged to come up with a solution. How do we solve these problems? However, all along, we know that additional use cases were thrown at IT. And these use cases fall under the use case classes of artificial intelligence and machine learning. And in our space, we know that in insurance, some of the important ones are storm and hail, right? You have the storm data, you have radar data, you have geographic data, you have property maps. Can you compare the two and come up with some kind of estimation of your risk exposure? And there are a number of those, fraudulent claim detection, which requires you to prepare a model based on learnings of previous claim submissions and determine whether a claim is fraudulent or not. And so on and so forth. There are other use cases such as, looking at an image of a VIN number in an odometer, for example. You use your cell phone to load it up, and then you combine it with an express pricing engine, you can get a quote on your phone. So all of these use cases provided some disruptive factors. On the input side of the data warehouse, it introduced various challenges. So one of them was that the volume of data was much, much bigger. There was a lot of variety in the data structures, as we talked about earlier. You may have the same data set that you are ingesting, but the underlying systems are changing or modernizing. So the data structure for the claim suite continue to change, for example. Data is coming at higher speed. We have, schema-less data. How do you fit into columns and rows, such as graphs and images? And then on the consumption side as well, we have another problem, right? Or new challenges, which EDW was never architected to solve. And those problems had to do with especially the batch-based nature of data warehouse. People would want the ability to be able to report in near real time, and EDW wasn't architected to solve that problem. Another new use case that has come up is algorithmic and machine use of data. And that data, these machines can deal with much more obscure, incomplete, cryptic data than other, compared to the human consumption. And they can ingest it at a much faster pace. So how do we serve a new class of users? So with all of these challenges, old and new, we need to come up with some kind of an approach. How do we solve these problems? So Syed, my colleague, is going to talk about some of the approaches that we can take to solve these problems. So Syed, I'm going to hand it over to you.
Okay, thank you, Ahsan. So let me just provide a preview of what I will be covering. First, we will go over the traditional EDW in terms of a generic reference architecture and where it struggles in terms of the challenges that Ahsan has been talking about. Then we will try to put up a modern reference architecture that we are proposing that would address the heavy-hitting modern challenges. Finally, we would try to showcase an actual case study where we are applying the modern reference architecture to an actual client situation. Okay, so now let's quickly jump into the traditional EDW reference architecture. This picture should be familiar because it contains pretty much run-of-the-mill layout of your traditional architecture. You have your sources, which comprise of your systems, your APIs, endpoints, your files. Collection is the first sort of flow that acquires data from those sources and lands it into a relational database, right? That's an entry point into this whole data ecosystem, if you will. Once landed, data from different sources gets cleansed, conformed, standardized into an enterprise-wide model, which is supposed to be objective. It's supposed to be used for BI type of use cases. This data in the standardized model is pretty vast and pretty deep. It's historical and has a lot of attributes in it. Do we need everything for every group? Not really. So we need to go through curation to create more targeted subsets of that data. They are cleansed, filtered, aggregated, repackaged for particular classes of use cases. Finally, we go into the consumption, right? When the developers of reports and analytics solution write specific solutions using things like Tableau, Power BI, or SAS, whatever, primarily go against the departmental marts on the curated sets or even EDW. Right, so that's the general sort of flow and life cycle of data through this architecture. Now, underlying this data lifecycle is a platform, is a technology stack, right? That's where we see the underlying infrastructure, the compute, storage, and networking resources. And on top of that rests the software layers with the RDBMS, where the data is persisted, and the ETL and job automation technology that is supposed to allow the data movement through different layers of this architecture. Right. The picture is still not complete without the mention of data management, because that's kind of the discipline that connects people, process, and technology to allow proper governance around the use, the security, the sharing of data inside and outside the organization. Okay. Now let's look at some areas where we have found the EDW architecture to show signs of struggle. Right. So, for example, start with flexibility. In the collection phase, we have often seen that changes in the source systems end up breaking the collection ETL or the landing ETL. Right. It's common observation. So that calls for a better and more resilient way to collect data from sources. When it comes to conformance, I'll just paraphrase the famous Rolf Hughes, who wrote a couple of books on agile data warehousing. He said we had to spend 3 million and 2 years to get the first report out of the EDW. And I'm sure many here will have heard similar sentiments in the industry. Another thing on the consumption side, right? Data accessibility out of the EDW is a challenge. The reason is that not everything is conformed day one. However, from the consumption side, sometimes you want to cast a wide net. So I'll give you an example. We were working on a branch workload management solution for claim branches for a PNC insurer, and they were trying to use different attributes in their models to understand how the load is distributed across branches. Since they did not know exactly how many attributes or which particular attributes they needed, it was a tough exercise to go back to the conform model, determine whether the attribute was there or not. And if it is not there, plan how it will be introduced in that model so that it can be used in the branch workload management models. Right, so that cycle is pretty time consuming, and that often forces businesses to just carve out their own plumbing directly from sources, and they bypass the standardization phase altogether, right? When it comes to data platform, scalability is a challenge, right? I'm sure some of us can relate to the situation where you realize that, when we realize that we have underallocated hardware, right, and the data is growing beyond the original estimates, right? This is a good problem, by the way, to have, and we can solve it temporarily by adding more hardware, right, by scaling up our RDBMS platforms. However, it cannot be done indefinitely. At some point, they max out. What do you do then, right? So it is a threat to the viability of the architecture in the long run. Similarly, sometimes we over-allocate instead of under-allocating, and then we are basically not using that resource, so we are wasting money, right? So there is a challenge with regards to scalability and elasticity that the traditional architecture inherently possesses. Let me go further. In terms of the data management, right, it is a challenge because it is top-down in nature, right? It is trying to cast a wide net across LOBs and making people agree on unified definitions. So for example, if marketing were doing reporting for earned premiums based on their own calculation, they might not agree initially to go with the definition that actuarial proposes because they might have a different perspective, right? Similarly, to even come up with unified models, let's say for policy lines, combining personal lines and commercial lines is a big undertaking. So the whole management becomes more complex. And by allowing a single view of truth and single perspective, it just becomes more inflexible, less flexible. So these are the challenges that we have seen in the traditional EDW reference architecture. And the hope is that the new approach will be able to address some of these challenges. So that's what the new architecture look like. Let's start building it up. First, the data sources, right? So we still have to deal with the existing sources, right? Your mainframe systems are there, your databases systems are there. But then you have some new types of data sources, your Twitter feeds, right? Your IoT streams. These are all very disruptive in nature in the sense that they are more high volume, high velocity, variability type of sources, which are not easily handled by the traditional technologies that normally pull data in batch mode, right? So we have to employ a different set of solutions to acquire data in real time from these different types of sources. Now let's look at where does that data go. So you acquire it using the right technology. It complements your traditional data sources where data is being pulled using the existing methods. That data ends up in a storage that we are proposing in this architecture, and which is pretty much the centerpiece of this strategy, right? It is the place that has two key characteristics that make it so important. One, it is schema-less, right? So data from traditional sources is handled as easily as the data from the modern sources. Second, it is durable and scalable, right? So you can put a lot of data in there. And the reason, because some of the use cases that Ahsan was talking about want to go back all the way, right? A lot of use cases need historical data. You don't necessarily have the ability to put everything in EDW forever, right? But this is more scalable, more affordable storage, so you can actually do that. Now let's talk about some benefits of that. So the example is, if you want to bring a new database from a new system in its entirety into the storage, you don't have to write a lot of new ETL, right? Similarly, because it is schema-less, all the changes upstream can be absorbed readily. So these are the benefits of using this architecture pattern. After that comes the conform layer, right? Now we are talking some elements of the model which need to be standardized, right? The centrality of the conform layer from the previous model has diminished somewhat. Previously, it was the starting point of everything. All the data needs were served starting with EDW. Now, the conform layer plays a role, but it is less critical. Why? Because level 0, the raw data layer itself, can serve a lot of needs directly, especially when users don't need the conform data. When two groups want to use data from their respective systems without that data being combined in a singular model without any kind of one-way transformations happening, sure, I mean, they can still go off of the level 0 storage. They don't have to use a conform model, but there are use cases which will call for conform model being used. For example, compliance reporting, right? They want a more stable and more integrated model. Sure, you make a more conformed model for those particular needs, but it is not needed for every need under the sun. What the advantage that this approach brings is that now you're doing good enough inclusion of attributes. You're not bringing in every attribute. Only what's critical is brought into the conformed layer. The curation step still remains in this picture. Why? Because on top of the conformed layer, you can easily produce smaller sets of data which are highly curated, and they are meant for targeted consumption. Right? So that is still a useful pattern. We will continue supporting that in our new architecture. The consumption here now is actually going off of all the 3 levels of storage. So that's the main differentiator between this architecture and the previous one, that the consumption is not bound to start with conformed data only. In the use cases side, we have the traditional BI and reporting use cases, and we have the new use cases, some of which Ahsan talked about. Both are supported from this unified data platform. And the example will be from a data accessibility that now if you want to run real-time fraud detection on claims, you can easily run that analysis on the data that just landed in the first level. It doesn't have to go up anywhere. You can still run your algorithm on the claim data that just came through. Now, the technology stack, right, that has also been enhanced. Why? Because now there is more variety of data that is coming through, so you have to be able to handle it. So starting with NoSQL, we can have upstream sources, the operational systems, which are now based on NoSQL databases. So this might be a viable architectural element to put in there, which will take the data from those sources and land it in a scale out on a scale out platform, because a lot of NoSQL platforms are very scale out by design. Then we have a role for a distributed computing and storage platform. This is, for example, Hadoop, right? But Hadoop is not the only one. You can have Azure Blob or Amazon S3. This is basically an application of the distributed computing paradigm, which allows you to do scale out at low cost, right? That's really the big benefit that this provides to this architecture. Then we have another player for acquiring data which comes as stream, right? So for example, you have social media or IoT data coming through, even NoSQL and distributed computing will be struggling. So you need more specialized solution for that. That's what streaming platform can provide. Example would be Kafka or Kinesis. You still have a room for RDBMS because, for example, conform data could still live in the RDBMS repository. You still have room for ETL and job automation because some level of ETL and data movement is still needed. However, there is a very important piece of this architecture that makes ETL, for example, less critical. And what is that? That is the distributed query engine, right? This is an engine that can work across sources, work across different levels of storage, work across different technologies, for example, between NoSQL and RDBMS, and still provide a unified interface from a consumption standpoint. So this speaks SQL. All the tools on the other side can only speak SQL. They don't have to know, for example, what's in the JSON platform, how the files are laid out. As long as this guy can cobble up and weave them together and present one unified view, which is what we call schema on read, because that schema is now embedded in the SQL that you write as part of the consumption development. So the benefit that it brings is really the scalability and elasticity that I was just talking about, especially the scale out nature of these technologies. They're by default, scalable. Similarly, if you are deploying some of these in the cloud, you can easily shrink and grow on demand. Data management in the new world, what does that look like? There's two key characteristics that we should talk about. One is it is tiered now, meaning there's different policies and methods available for different levels. They are not controlled through the same uniform singular approach. So for example, level 0 would be more forgiving when it comes to referential integrity and applying reference data conformance. And level 2 might be highly conformed, and it might have strict referential integrity when it comes to lookup data and reference values, right? So the governance will apply the right level of control in conformance to any of these levels. That's why it's tiered. Similarly, it is federated, right? What that means is that you can develop your model based on the user input rather than starting from some IT person's vision that this is what the model should look like. It's really, you're growing the conformed and the curated data sets based on specific use cases. So you could very well start with a level 0 for everything, and then eventually find out what is it that the users need as conformed data, and then only start building up the conform layer, and so on and so forth. So this is really the summary of our proposed approach that would address some of the key challenges faced by the EDW and the disruptive use cases that Ahsan was talking about.
Thank you, Syed, for sharing us the modern thinking around the modern data platforms. So this reference architecture that we have shared with you, this is grounded into our customers' actual problems and their solutions. It's a very pragmatic approach and an evolutionary approach that our customers are finding very useful. But one thing to understand is this is a reference architecture, and every reference architecture just gives you a starting point. If you're looking at what do you need to do in your organization, you might be thinking, how does it apply within my organization? Does it even apply? Or maybe I can just take it as is and propose this is the direction we probably would move into, but you can't really jump there so quickly. You take this reference architecture and then you marry it up with the organizational context. You look at what are the existing data infrastructure, what are the existing technologies, what are the existing business processes, and then you marry the two and come up with something that is specific to our enterprise or an enterprise. So with that in context, we're going to share you a real life case study where how we applied this reference architecture in the real world. The example we're going to share with you is for a multi-line property insurers. We picked up an example from a P&C space we thought would be relevant for the audience. So it's a multi-line property and casualty insurers who insures its customers both on commercial and personal properties. The problem that they had was they had the EDW-based data architecture, but then they were faced with the similar challenges that we talked about earlier. And it was sort of resulting in the same problem that we talked about as well, where, you know, actuarial and people who were doing advanced analytics, they needed some additional capabilities. IT wasn't ready for them, so they started to build those capabilities themselves. And then it was kind of the repeat of the same thing. They're building their own data infrastructure. You know, IT, shadow IT is slowly building up. They said, how do we address that problem? What kind of strategies that we can come up with? And they wanted to make sure that they can preserve the existing investment, a lot of time and money that invested in their existing data infrastructure. How can we preserve that? So we engaged with them and did analysis and came up with a strategy that Syed can walk you through for that specific implementation.
Okay, so this is how we are attempting to apply the reference architecture to this particular client engagement. Right, I've highlighted some elements in the diagram which are noteworthy. So starting with, for example, level 0, we have a data lake pattern that we are applying here. It allows for full fidelity, holistic blending of data from both their traditional sources and the modern data sources that are on the horizon for them. On top of the data lake, level 1, we have a EDW, right? Primarily because it is an existing asset. It contains a conform model that is useful for the enterprise, and it fits nicely in our reference architecture, right? EDW then proceeds to feed the dimensional marts. In the future, the hope is that EDW will be fully integrated and fed from the level 0. Right now, there is some direct plumbing from sources into EDW that we are eventually going to phase out. Right? Another interesting thing that this solution contains is the ability to spin up analytics sandboxes, especially to be used by data scientists for data exploration. So these are the key sort of additions or sort of identification of concrete elements into the reference model. Similarly, in the data platform side, right, we are using a distributed storage platform. We're not using NoSQL, but we are using a distributed computing platform. We are using a streaming platform based on some of the sources that are planned to be included in this architecture. Similarly, we are using or proposing to use a distributed query engine so that data from the RDBMS could be combined with data from the distributed storage, right? Let's now look at the data pipeline. So data from batch system originate from like claims and policy admin, public files and whatnot, right? When it comes to the more advanced sources, the plans are to be able to support things like call center logs, which are highly unstructured, social media postings, and I think the first use case actually is about image processing from property inspections. That's what we are starting off with. On the consumption side, we are going to have to support the existing use cases, claim and policy dashboards, branch workload management. We are also furnishing enhanced self-service reporting capabilities. In the area of disruptive, more cutting-edge use cases, right? We are supporting the image processing of the odometer reading and VIN numbers that we receive. We will also be able to support call center quality analysis. Let's now look at the technology stack, right? So for the distributed and storage computing platform, we are using Hadoop, and it's a commercial distribution by Hortonworks. For the streaming platform, we are using Apache Kafka. For RDBMS, which is the platform on which EDW is built, it is SQL Server. As for the ETL, previously it was a mix of Veriscape and SSIS, which is basically Veriscape is an ELT tool, and SSIS was used for automation. Now we are adding Apache Scoop and Kafka as well. So Veriscape is able to use Scoop and Kafka to be able to move data around different levels of this central piece. When it comes to distributed query, Hive is the current selection. It might change. We might be able to introduce some more advanced solutions like Facebook Presto, but that's where the things currently stand. Similarly, for the governance side, right, we are using the built-in support for data lake management that Podium platform offers. That's the platform that is actually that's the vendor that is furnishing our data lake. Right? It does cataloging, profiling, and lineage management. On the other hand, EDW was already governed using Collabra, right? So now we are actually using an integration between Podium and Collabra that would allow us to have an end-to-end perspective and traceability of data as it flows through different levels of conformance, right? So this is the sort of the concrete details on the implementation of this reference architecture, and it is still evolving. We might add more pieces to this puzzle to provide more capabilities, but that's where it stands today.
So thanks, Syed, for explaining how we have implemented this at one of our customers. Now let's talk about the takeaways. What is it that we have learned, and what are the key takeaways from the approach that we have proposed? So one of the important things to note is that the modern data platforms are more complex than before. As you saw, in the proposed architecture, it is supporting much more complex use cases. It is ingesting, a wide variety of data sources, and between the ingestion and consumption, you saw we were applying multi-level governance and different multi-level data layers. So it is a complex architecture. So when you're thinking about architecting a solution, you really have to put some serious thought into how we're going to architect this. Take the reference architecture and then say for one organization, what the solution is going to look like, for another organization, what the solution is going to look like. And then once you have that, and as Syed pointed out, the next level of problem is finding the technology stack, selection of the technology stack, which is second set of challenges that you want to make sure you make the right decisions. And then once you have made some decisions on the technology stack, then there are further layers to be discussed, which is outside the scope of this discussion, such as where are we going to deploy it, how we're going to deploy it, and so on and so forth. Another important takeaway is that the evolutionary approaches are available to modernize existing data platforms. You don't have to throw away your existing investment, or you don't have to do major refactoring. As you saw in a previous example, we were able to internalize the existing data warehouse in the new approach. And we built everything around it. And we have a plan to cut the old cords over time based on a thought out plan. So if you are thinking about modernizing your data platform, how to solve these problems, and if someone is proposing you, hey, we need to take a drastic approach, hopefully this presentation will provide you a different perspective, and you would be able to look at it from a different angle as well, and would be able to leverage your existing data investment significantly. And the last one, very important, is that you should start your journey as quickly as possible of modernization. We feel that is fairly important, that these modernization, a lot of especially insurance companies are fairly behind. They need to catch up to the wave and get to where the rest of the industry is. As long as you're not doing it, all you're doing is you are piling on more and more technical debt. So our recommendation is to start your modernization journey as quickly as possible. So those are our takeaways. And with that, it kind of completes our webinar. And perhaps now we can look at any Q&A. So if those who are attending, if you have any questions, if you haven't submitted yet, you can go to the control panel of the webinar, click on the Q&A button, and submit your questions. So let me see if we have any questions that have been submitted so far. Let me see. Okay, it kind of looks like we have a few questions. So the first question we have is EDW going to disappear from future architecture? Oh, it's a very interesting question. Syed, you want to take that?
Sure. So as you guys probably can appreciate, at least in this webinar, we are proposing a evolutionary approach where EDW finds its place as a conformed repository. Right? It might not be as central anymore. That's really the difference. That it is not the first repository that starts serving the BI needs. Now it is one of the repositories, right? So what you conform is based on where the agreements are or where the critical needs are across the board. Otherwise, you don't have to conform. So yeah, I mean, EDW might not have exactly the same name in the future, but its role will be there. It is part of the overall ecosystem of data. And that's why people should not feel nervous about letting go of these important assets they have.
Thank you. So we have a couple of questions. Let's see how many of those we can get through in the remaining few minutes we have. So the next question is, does this approach prescribe cloud migration? So I have actually some thoughts on those. So as far as this approach is concerned, as I was talking, you think about the problem in various layers. You talk about the reference architecture, then specific architecture of your solution, then you talk about technology, and then in that discussion, you also come to the deployment architecture. How are you going to deploy your solution? And cloud comes into play when you're talking about deployments. And these days, cloud doesn't come with only deployment option. It also comes loaded with other bells and whistles as well. It gives you compute and storage, significant compute and storage options as well. So as you saw in the reference architecture that we shared, there are various boxes that you saw, and for each of the box, you have to carefully analyze and see what is the best deployment for that box from a compute perspective, from a storage perspective, from a deployment perspective, from an accessibility perspective, and you may end up with a hybrid, more than likely a hybrid, where some of the pieces of the puzzle would be on the cloud and some of them would be on premise. And when we talk about cloud, you can build your own private cloud, which can have a lot of very similar capabilities that you would find in some of the major big public clouds such as Amazon or IBM. So, I mean, cloud doesn't necessarily mean going to a commercial cloud provider. You can deploy it within your data center as well. So it doesn't necessarily prescribe like a commercial cloud migration, but cloud provides a lot of incentives that you cannot just easily pass those on. So think about it, if you, as a cloud-first strategy, if you feel that there is no other option, you have to have that application deployed within your premises, then you go with that option, but always evaluate cloud as a viable option. That would be my recommendation. Let me look at, we have a few more minutes. The next question I have is, where do you fit operational data stores?
Okay, I think I can take a shot at that. So in this presentation, I mean, we have generally favored the architecture that supports BI and analytics needs, right? So ODS and MDM fall a little outside of that sort of, if you will, scope, right? They have a connection to what we do, right? For example, data lake can feed things like ODS. However, it is not really called out in this architecture, so I cannot really do justice in this Q&A section to that topic. We might end up having to do another presentation that talks about the other types of uses that can emerge out of this overall sort of architectural framework.
So there are a few more questions, but perhaps we can take one more question. I want to be respectful of everyone's time as well. So that question is about what are the challenges in the adoption of this architecture?
Yeah, I think I can also at least try to provide some high-level ideas around the challenges, right? So one thing I keep sort of sensing in the industry is the lack of skills in a way, right? So primarily because ETL is now a fairly established discipline, right? You find a lot of skill set that is trained in ETL, and their thinking is oriented around that, right? But now we are kind of redefining the picture somewhat, and a lot of people are not ready to change their skill sets. Now it is a mix of tools. It's not just one or two tools that you have to leverage, right? So you have to be very open-minded. You have to be able to leverage things like Hadoop, bunch of Apache projects that were not as mainstream in the past. So that means that finding the right team is very critical a team that is not solely dependent on one or two vendor tools. They have somewhat of an architectural perspective that they bring with them. It's very important to have that type of team. Another thing I see is that there's a little bit of lack of clarity on what is the best fit for what level, if you will, from the lake example, right? What is the best fit for level 0, right? Can anything be delivered using level 0 data? Can or rather, can everything be delivered? Maybe yes, but is it the right approach, right? So that's why this architecture opens up a lot of possibilities, and then we have to be selective and objective about which one we pick based on what criteria we establish. Otherwise, it would become hard to govern and evolve and grow these things. So these two challenges, which means basically you need good architectural patterns in the end, so that you can guide your thinking aided by them, right? And that's what we will propose as a general strategy.
Yeah, I agree. And a few things that I'll add to it is that I think a lot of it depends on the leadership team as well. How does the leadership, your IT leadership team sees the future? If they see the future and see, hey, we need to make a move, we need to make certain changes. If that realization is not there, then that would become a very big barrier. If we have seen a lot of examples where at a CEO level, there is realization that something needs to happen, but at CIO level, that realization is not there. And we are seeing that manifesting in the organizations with the formation of these digital transformation groups, and these are sometimes outside of the CIO's office sometimes, or like the innovation groups. And these are the people who are working on all these modern and upcoming solutions, whether they have to do with customer experience, data and analytics, mobile solutions, and a higher engagement, etc. So those things have been taken away sort of from IT because they didn't step up to the plate, but someone had to take charge and deliver that capability to the organization. So CEOs have taken that step and given it to someone else and are asking IT, hey, you guys just focus on maintaining these applications, keep taking the backups, make sure the lights are on. But we need a different set of thinking, a different set of talent to solve these new problems. So that is another barrier to solving these problems or adoption of the modern architectures. We do have a few questions, but unfortunately, because of time, we may have to stop here. We do have our email addresses right here. So if you have any questions, we'll be happy to answer those. You're free to email us or contact us, and we can answer your questions there. With that, Doug, I will hand it over to you. Thank you very much.
Thank you for attending our webinar today. Thanks also to Ahsan and Syed from Xby2 for the content. We hope you found it not only useful, but helpful as you continue along your own digital journey. Should you have questions about the content in today's event, please reach out to Ahsan. The contact points will also be included in the next email to you. Please do send comments about today's webinar and any suggestions about topics you would like us to cover. Watch for the note with details about the recording and the slide deck. Check out the details for our one-day events coming up, InsurTech TO 2018 on Wednesday, November the 7th, and that's titled Driving Advantage from InsurTech. And secondly, an MGA Technology Symposium on Tuesday, November the 27th. Both of these events will be in downtown Toronto. More webinars are coming as well. The next is almost finalized, but the date and details not quite confirmed, tentatively October the 17th. In the meantime, thanks again for attending. I wish you all a good fall season. This ends our event for today.